العالمين.
All right, well, how about some other building blocks? Lists are going to be so incredibly useful in Python, just as arrays were in C. But arrays are annoying because you have to manage the memory yourself. You have to know in advance how big they are, or you have to use pointers and malloc or realloc to resize them. Like, oh my God, like the past 2 weeks have been painful in that sense. But Python does this all for free for you. In fact, there's a whole bunch of functions that come with Python that involve lists, and they'll allow us ultimately to do things again and again and again within the same data structure. And for instance, we'll be able to get the length of a list. You don't have to remember it yourself in a variable. You can just ask Python how many elements are in this list. And with this, I think we can solve some old problems too. So let me go back here to VS Code. Let me close Mario and give us a new program called scores.py. And rather than show the C and the Python now, let's just focus on Python. And in scores.c, way back when, we just averaged like 3 test scores or something like that, 72, 73, and 33 a few weeks ago. So if I want to create a list in this Python version of 72, 73, 33, I just use my square bracket notation. C let you use curly braces if you know the values in advance, but Python's just this. And now if I want to compute the average, in C, recall, I did something with a loop. I added all the values together. I then divided by the total number of values, just like you would in grade school, and that gave me the average. Well, Python comes with a lot of super handy functions, not just length, but others as well. And so in fact, if you want to compute the average, you can take the sum of all of those scores and divide it by the length of all of those scores. So Python comes with length, comes with sum. You can just pass in a whole list of any size and let it deal with that problem for you. So if I want to now print out this average, I can print out average colon, and then I'll plug in my average string for a variable for interpolation. Let me make this an F string so that it gets formatted. And let me just run Python of scores.py. And there's my average. It's sort of rounding weird because we're still vulnerable to some floating point imprecision. But at least I didn't need loops, and I didn't have to write all this darn code just to do something that, you know, Excel and Google Spreadsheets can just do like that. Well, Python is closer to those kinds of tools, but more powerful in that you can manipulate the data yourself. How about, though, if I want to get a bunch of scores manually from the user and then sum them together? Well, let's combine a few ideas here. How about this? First, let me go ahead and import the CS50 getInt function from the CS50 library, just so we don't have to deal with try and accept or all of that. And let me go ahead and give myself an empty list. And this is powerful. In C, there's no point to an empty array, because if you create an empty array with square bracket notation, like, it's not useful for anything. But in Python, you can create it empty because Python will grow and shrink the list for you automatically as you add things to it. So if I want to get 3 scores from the user, I could do something like this. For I in range of 3. And then I can grab a variable called score or anything. I could call getInt, prompt the human for the score that they want to type in. And then once they do, I can do this, thinking back to our object-oriented programming capability now. I could do scores dot append, and I can append that score to it. And you would only know this from having read the documentation, heard it in class in a book or whatnot. But it turns out that just like strings have functions like lower built into them, lists have functions like append built into them that just literally appends to the end of the list for you. And Python will grow or shrink it as needed. No more malloc or realloc or the like. So this just appends to the scores array, the scores list, that score, and then again and again and again. So the array starts at, the list starts at size 0, then grows to 1, then 2, then 3, without you having to do anything else. And so now down here, I can compute an average with the sum of those scores divided by the length of the total number of scores. And to be clear, length is the total number of elements in the list. Doesn't matter how big the values themselves are. Now I can go ahead and print out an F string with something like average, colon, average, and curly braces. And if I run Python of scores.py, I'll type in, just for the sake of discussion, the 3 values. I still get the same answer. But that would have been painful to do in C unless you committed in advance to a fixed size array, which we already decided weeks ago was annoying, or you grew it dynamically using malloc or realloc or the like. All right, what else can I do? Well, there's some nice things you might as well know exist. Instead of scores.append, you can do slight fanciness like this. like if you want to append something to a list, you can actually do plus equals and then put that thing in a temporary list of its own and just use what is essentially concatenation, but not concatenation of strings, but concatenation of lists. So this new line 6 appends to the scores list this tiny little list I'm temporarily creating with just the current new score. So just another piece of syntax that's worth seeing that allows you to do something like that as well. All right, well, how about we go back to strings for a moment? And all of these examples, as always, are on the course's website afterward. Suppose we want to do something like converting characters to uppercase. Well, to be clear, I could do something like this. Let me create a program called uppercase.py. Let me prompt the user for a before string, as by using the input function or getString, which is almost the same. And I'll prompt the user for a string beforehand. Then let me go ahead and print out, how about the keyword after, and then end the new line with nothing, just so that I can see before on one line and after on the next line. And then let me do this. And here's where Python gets pleasant too with loops. For C in before, print C.upper end equals quote unquote, and then I'll print this here. All right, that was fast, but let's try to infer what's going on. So line 1 just gets input from the user, stores it in a variable called before. Line 2 literally just prints after, but doesn't move the new line, the cursor to the next line. What it then does is this. And in C, this was a little more annoying. You needed a for loop with I. You needed array notation with the square brackets. But Python, if you say for variable in string, so for C, for character in string, Python's going to automatically assign C to the first letter that the user types in. Then on the next iteration, the second letter, the third letter, and the fourth. So you don't need any square bracket notation. You just use C, and Python will do it for you and just hand you back one at a time each of the letters that the user has typed in. So if I go back over here and I run, for instance, Python of uppercase.py, and I'll type in, how about David in all lowercase and hit enter, you'll now see that it's all uppercase instead by iterating over it, indeed one character at a time. But we already know, thanks to object-oriented programming, strings themselves have the functionality built in to not just uppercase single characters, but the whole string. So honestly, this was a bit of a silly exercise. I don't need to use a loop anymore like in C. And so some of the habits you've only just developed in recent weeks, it's time to start breaking them when they're not necessary. I can create a variable called after, set it equal to before.upper, which indeed exists, just like .lower exists. And then what I can go ahead and print out is, for instance, let's get rid of this print line here and do it at the end, after, and print the value of that variable. So now if I rerun uppercase.py, type in David in all lowercase, I can just uppercase the whole thing all at once, because again, in Python, you don't have to operate on characters individually. Questions on any of these tricks up until now? No? All right, how about a few other techniques that we saw in C that we'll bring back now in Python? So it turns out in Python, there are other libraries you can use too that unlock even more functionality. So in C, if you wanted command line arguments, you just change the signature for main to be void, instead of void, to be int argc, comma, string argv, open brackets for an array, or char star eventually. Well, it turns out in Python that if you want to access command line arguments, it's a little simpler, but they're tucked away in a library, otherwise known as a module called sys, the sys or system module. Now, this is similar in spirit to the CS50 library in that it's got a bunch of functionality built in, but this one comes with Python itself. So if I want to create a program like greet.py in VS Code here, let me go ahead and do this. From the sys library, let's import argv. And that's just a thing that exists. It's not built into main because there is no main per se anymore. So it's tucked away in that library. And now I can do something like this. If the length of argv equals 2, well, let's go ahead and print out something friendly like hello, comma, argv bracket 1, and then close quotes. Else, if the length of argv is not equal to 2, let's just go ahead and print out hello world. Now, at a glance, this might look a little cryptic, but it's identical to what we did a few weeks ago. When I run this Python of greet.py with no arguments, it just says hello world. But if I instead add a command line argument, like my first name, and hit enter, now the length of argv is no longer 1. It's going to be 2. And so it prints out hello David instead. So the takeaway here is that whereas in C, argv technically contained the name of your program, like /hello or /greet, and then everything the human typed, Python's a little different in that because we're using the interpreter in this way, technically when you run python of greet.py, the length of argv is only 1. It contains only greet.py. So the name of the file, it does not unnecessarily contain Python itself, because what's the point of that being there omnipresently? It does contain the number of words that the human typed after Python itself. So argv is length 1 here, argv is length 2 here, and that's why when it did equal 2, I saw hello David instead of the default hello world. So same ability to access command line arguments, add these kinds of inputs to your functions, but you have to unlock it by way of using argv instead in this way. If you want to see all of the words, you could do something like this. Just as if we combine ideas here, for I in range of, how about length of argv, then I can do this, print argv bracket I. All right, a little cryptic. But line 3 is just a for loop, iterating over the range of length of argv. So if the human types in 2 words, the length of argv will be 2. So this is just a way of saying iterate over all of the words in argv, printing them one at a time. So python of greet.py, enter, just prints out the name of the program. Python of greet.py with David prints out greet.py and then David. I can keep running it, though, with more words, and they'll each get printed one at a time. But what's nice, too, about Python, and this is the point of this exercise, honestly, this looks pretty cryptic. This is not very pleasant to look at. If you just want to iterate over every word in a list, which argv is, watch what I can do. I can do for arg, or any variable name, in argv. Let me just now print out that argument. I could keep calling it I, but I seems weird when it's not a number, so I'm changing to arg as a word instead. If I now do python of greet.py, it does this. If I do python of greet.py David, it does that again. David Malin, it does that again. So this is, again, why Python is just very appealing. You want to do something this many times, iterate over a list, just say it. And it reads a little more like English. And there's even other fanciness, too, if I may. It's a little stupid that I keep seeing the name of the program, greet.py. So it'd be nice if I could remove that. Python also supports what are called slices of arrays. Slices of lists, even though I get the terminology confused. If argv is a list, then it's going to print out everything in it. But if I want a slice of it that starts at location 1 all the way to the end, you can use this funky syntax in between the square brackets, which we've not seen yet, that's going to start at item 1 and go all the way to the end. And so this is a nice, clever way of slicing off, if you will, the very first element, because now when I run greet.py David Malin, I should only see David and Malin. If I only want one element, I could do 1 to 2. If I want all of them, I could do 0 onward. I could give myself just one of them in this way. So you can play with the start value and the end value in this way to sort of slice and dice these lists in different ways. That would have been a pain in C just because we didn't really have the built-in support for manipulating arrays as cleanly as this. All right. Just so you've seen it too, though this one is less exciting to see live, if I go ahead and create a quick program here, it turns out there's something else in the sys library, the ability to exit programs, either exiting with status code 1 or 0, as we've been doing anytime something goes right or wrong. So for instance, let me whip up a quick program that just says if the length of sys.argv does not equal 2, then let's yell at the user and say, you're missing a command line argument. Otherwise, command line argument. And let's then return sys.exit1. Else, let's go ahead and logically just say print a formatted string that says hello as before, sys.argv1. Now, things look different all of a sudden, but I'm doing something deliberately. First, let's see what this does. So on line 1, I'm importing not argv specifically. I'm importing the whole sys library. And we'll see why in a second. Well, it turns out that the sys library has not only the argv list, it also has a function called exit, which I'd like to be able to use as well. So it turns out that if you import a whole library in this way, that's fine, but you have to refer to the things inside of it by using that same library's name and a dot. to sort of namespace it, so to speak. So here I'm just saying if the user does not type in 2 words, yell at them with missing command line argument and then exit with 1. Just like in C, when you do exit 1, just means something went wrong. Otherwise, print out hello to this. And this is starting to look cryptic, but it's just a combination of ideas. The curly braces means interpolate this value, plug it in here. sys.argv is just the verbose way of saying go into the sys library and get the argv variable therein. And bracket 1, of course, just like arrays in C, is just the second element at the prompt. So when I run this version now, Python of exit.py, with no arguments, I get yelled at in this way. If, however, I type in 2 arguments total, the name of the file and my own name, now I get greeted with hello, David. And it's the same idea before. This was a very low-level technique, but same thing here. If you do echo $? Enter, you'll see the exit code of your program. So if I do this incorrectly again, let me rerun it without my name, enter, I get yelled at. But if I do echo $? There's the secret 1 that's returned. Again, just to show you parity with C in this case. Questions now on any of these techniques here? All right.